welcome back to Advent of Code. Today we're working on day 22 of the year 2021, this year, except if you're watching in the future. I didn't finish day 18 and I did skip day 19 because I wasn't having fun and this felt a bit too hard to do on stream. So yeah, I just skipped them because if I do something when I'm having fun, it's good for you, but if I'm not having fun, it's not fun to watch. So yeah, that's why we're getting back to day 20. And we're gonna start with this little example here. So as usual, we're gonna start with some input parsing. So first thing to do is to make sure the first line is actually on one line, because they mention that the puzzle input, this is just one line, I believe. Is it? Oh, confusing. Yeah, exactly. So my display here is weird, but the first line is just one line. So that's one thing to be careful when copying this. Yeah, so we're gonna start with doing some input parsing. For that, we take our template that we're using every day and use it here. So here what we want to do is start by splitting by a double line return here in order to get this thing here. And that's it here. We're gonna say we actually need to rename that. First thing is the algorithm, and the second thing is the data, and we're just going to use data for now because we want to here say const image equal data.trim.split on a line return, and that should be good. So here we're just going to be logging the algorithm and data. Node, okay, so many pop-ups here. Node day 20. Yeah, I need to speak a bit louder. You guys told me. Oh, day 20. Okay, so here, forgot to change that. Okay, we have all that we need. We should have, put like a, yeah. Using these curly brackets enable us to make sure we don't have like a bad line return at some point. Everything looks good. We can proceed to the actual part 1. So what we need to do is to do what is called a convolution, which means we need to go through each pixel of the image and create a new one. So one thing that's tricky is that this is an infinite grid. So meaning we're gonna need to add 1 pixel all around the image on every turn. So yeah, that's something we're gonna need to do. So yeah, let's do that. So here we're gonna need to do a double for loop. So let's start with a double for loop. We're gonna do I starts at -1 instead of starting at 0, because we have this infinite grid. So we need to, when we have an image like that, we need to start with this pixel here. That's actually not changing, but the next pixel here is changing. So here it's between -1 and image.length +1, and then we need to do another for loop. We start at -1 as well, and we do image of 0.length +1. So this is here for each line, and then for each column of one line. And here we're gonna say function get y x here, You're gonna say if y is, we can say actually return image of y of x, and here we can say if this is undefined, here we can return an empty array, and then let's actually do this. If image of y, if type of image of y is not undefined, then return, no, we say type of that, and type of image of y of x is not undefined, then we can return that, otherwise we just return a dot. Yeah, that should be good. That should be good. So here basically we are avoiding out of bounds exception, out of bounds values. So if we have like if we are checking, instead of doing image of I can be -1, which would lead to an undefined value, so that would be a lot of mess. Here we're just going to do get, and that's going to simplify our job a lot. So here we are on this specific point, but then we need to do a double for loop for the convolution. Actually, do the convolution, and actually let me check convolution. This is this is the thing I'm looking. Let's do that in English. Yeah, if you want to read that convolution matrix and everything, that's just like, I think, the right term for what we're doing here. So here for a convolution, we just need to do the double for loop. That's it. Actually, let's rename, before we do the for here, I would like to rename the I. Here we actually would like to use y, and here we would like to use x. That looks a bit better. And then here we can use, in this for loop, we can do I should be between -1 and 1, and j should be between -1 and 1, and here const boolean, let's say binary, no, so it's let binary, it starts with nothing, and here we can say binary plus equal, so this is get of y plus I, x plus j. Yeah, we just need to get this information, and we need to do if this is equal to hash, then we store 1, otherwise we store 0. That is what we store in this binary string. We can say then const index equal parse int binary in base 2, which is giving us the index in base 10. Here we can return, here let's actually store that somewhere in another function, convolution. We're gonna call that convolution. That's it. So const result equal an array here. Then here we do result that push an empty array here. Wait, here it's going to be const. We need to create this array, const current. We create the array, and here we do result that push current. So here we can do current dot push the Oh yeah, by the way, I'm just like coding, like I'm keeping the spec. I've kept the spec in my head just before, so maybe I need to share a bit more explanation. So because we have this infinite grid, we need to go through each element here of this line, this line, this line, and then for each element we need to do this thing where we check when we get the 9 elements that are around them, we make that, we concatenate that into this string, except we transform the dots into zeros and the hash into ones. Then this we convert into decimal. Then we take inside the algorithm the character that is at this specific index. So this is what we're doing here. We're saying algorithm of index, and yeah, this is what we return. So now the image should have this character. Yeah, so when we do this here, this character changes to this character. So basically this is what we do here. The character yx changes to this character that we computed. And here we should do, actually, here instead of doing that, we should here do current.join with space. So basically here result is going to be an array of strings like the input. Here we can return result here. So basically part 1, we're going to be logging the table. We're going to be logging the, is it data? What is it again? Image here. Logging the image, and then we console the table, the convolution of image. Okay, so here instead of having, we need to pass the image. Instead of using the image that is here, we need to pass the actual image. We can pass the algorithm. So that's, this is just using local variables instead of global variables. That's a little bit better. You know what? Let's actually make that inside an object. That's something that I really like that. Let's do the same for get. Actually, get. Yeah, no, let's not go too crazy with that. Let's see. Okay, here this is the first value, and here this is second value. This looks like this image here. Yeah, so this image is the second value, is looking like that. That's really good, and we can actually do so this is here we're going to say function double convolution image algorithm. So here we're going to say tmp equal convolution of image algorithm, and then we return, except here instead of passing image we pass tmp, which is the result of the first convolution. So here we can actually use double convolution, and this is the resulting image, which doesn't look right. It does not look right. So this looks good between this and that, except here it looks like a mess. It looks like exactly the same array, except we have some padding around it, which is weird. So we have our first bug of the day. Not something that I'm really happy about, but you know what? That's fine. That is fine. Enhanced a second time. So let's make sure we are using the thing here. Image. Oh, see here, get is using the image at the top. Here, get should always be using the local variable instead of a global variable. Otherwise, we are failing. So yeah, that's one of the mistakes that I'm doing often. I mean, when coding these things is using a global variable instead of a local one. And now it fixed everything. It looks exactly the same, which is perfect. And now we just need to function count light. Oh, here we can just put an image, and here we're gonna say, what do we do to count the light? We should say here we're gonna use we're gonna say image.join. So we are concatenating all of the strings inside one big string. We do replace all the dot by nothing, and then we do dot length, and this is a hack to not have to do crazy stuff. So here we return console log. We can hide all of this debugging. Count light of double convolution, and this should give us no, we have something. Replace all is not a function, so that could be because of the version of JavaScript I'm using. Anyway, let's use that should be, we are going to use an older version. We take a string here, dot replace. We take this regular expression is a dot that is anywhere, so we have to escape the dot because the dot has a special meaning in regular expressions. So this is an actual dot, and global flag means checking all of them, and we replace all of them by nothing, which means we delete all of the dots from this string. So we just keep the hash, and we take the length of the string. We have 35, which looks really nice, so we're just gonna be taking that, pasting it here, and let's see. We have a big number. I mean, not super huge, but it looks like a good big number. Not the right answer. Your answer is too high. Make sure you're using the full input data. Oh, please wait 1 minute. Well, yeah, we're going to spend 1 minute to actually debug that. Okay, so I guessed something. That must be a small issue. Let's try again with the input here. So here we need to make sure, actually I need to save this data somewhere. Maybe I need to, next year, maybe I change the way we store the test inputs. Anyway. Okay, so that's our test input. Let's try, yeah, we have 35, that looks good. Let's see. Oh, one thing we need to make sure is 0 is one thing that's super important in my input. Oh, that looks not cool. There's a hash here. Okay, so I will explain what happens. So let's say you have just dots here. So dot, 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 dot. If you have 9 dots, then it means it's just zeros, right? 9 dots, it means it's just dot, 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 dot. It means it's just binary number 0 here. And 0 is the first element of the algorithm. So yeah, here that looks bad. So yeah, here in our full input here, the value 0 is a hash. So it means that when we have just zeros, we return a hash. I don't know if that's normal, correct? I think that looks not good. Only a portion of the... Yeah. The problem is that basically this, because it's an infinite space, in my mind, I mean in the current version that I've implemented, we're just gonna fill the infinite space with ones because of this. So I need to figure out so here, yeah, for example, when you look, yeah. So yeah, there is this infinite size that I'm not sure how it does work. Every pixel of the infinite output image needs to be calculated exactly based on the relevant pixel of the input image. Okay. So let's say we do that once. It means that there is an infinity of ones. And if we do that second time, because it ends with a dot, there will be an infinity of zeros. So yeah, we just have a flash where everything is a hash, and then we revert back to a flash where everything is a dot. So that's one edge case that I didn't take into account. That's a little bit painful, but we are gonna have to make this work. So we can actually try to make this work by doing the dot. That's just like a simple example. If we have a dash here and a dot in the end, what do we have? We have 16. And what it should be is that because we have a dash here, everything should flip to be a dash. And then because we have a dot in the end, everything should flip again to be empty. So so we need to say, okay, here actually in the double convolution here. So here in the convolution we need to say default is, and by default this is a dot. How do you do that? How do you do that? Is that the way to set up a default in a unstructured? Anyway, let's not do that, you know. Here we're just gonna say default. So here get so here we need to pass a default. So many annoying stuff. Default, and here we just return the default here. Why is it? Oh, default is a reserved word. Okay, so we need to change that. Default char. Okay, so here with that, I could be able to say, okay, default char is a dot. Yes. Okay, default char here, default char, and default char. So here we say by default, here the default char is a dot, and then if algorithm of 0 is equal to hash, actually let default char equal a dot, and if the algorithm of 0 is a hash, then we say default char is equal to hash, and then here we send again default char. Let's see, that should be 0. Okay, so we fixed what I believe was the problem. We can try again with our our basic test case. Okay, basic test case worked. Now we're going to test on the full input. What was the previous thing? Oh, 24, and now we have 17. Let's see, is that correct? Yes, okay. So that was an edge case that we didn't take into account, that we found manually. We were very lucky to find this specific edge case, the fact that the algorithm starts with a hash. Let's go to part 2. Okay, that was one thing that I was expecting. It's just now we need to enhance that 50 times. So here we're gonna say we're gonna change, and we're gonna say, oh, actually let's keep that. Let's keep that double convolution, because that's a bit funny to look back on the code and see that there is double convolution. Here we're gonna say multiple convolution, and here we're gonna say steps, and we're just gonna say equal 50 because that's what we care about. And we're gonna say yeah, we're just gonna be doing a for loop. That's just gonna be a massive for loop. Yeah, so we need to do that 50 times. I'm gonna say let current image equal image, and here we're just gonna say current image equal image. Actually, I think I can just skip the current image, and I can just say, okay, we can store the image here, and we say if algorithm 0 is equal to a hash, hey, there's going to be another edge case here. So we're going to need to use this thingy here. Actually, you know what? Yeah, we are going to just, okay, I'm going to copy paste that here. And here, instead of double convolution, we're going to say multiple convolution. With here, we can reuse the simple edge case here. Okay, and here, let's just do steps equal to. The idea here is just to make sure we have 35 again. And here, as you can see, there's just something that's not right. Oh yeah, here we forgot to use steps. Steps 35. Okay, so that looks correct, except we need to actually do our small edge case here. Here we want the first to be a hash and the last to be a dot, which means it's just gonna be flipping. First step, it's all white. I mean, step 0, all white. Step 1, all black. And it's gonna do that. It's gonna do that. So here we need to actually do something a bit smarter. We're gonna say if default char is equal to a dot and algorithm 0 equal hash, we change the default char. We're going to say the same if this is a hash and algorithm of, and the last thing, so algorithm.length -1 is, and algorithm.length -1 is the value we can actually do parse int 111 111 111 in base 2. We can do that as well. That's just the same, the equivalent, I believe. In that case, if this is a dot, then we move and use a dot now. So we actually messed up our first step. How come we changed this step? We didn't touch the code. Good. You know what? When you do this, it's better to take everything you wrote, comment it, and see if it changes anything. It's a 0. Oh yeah, of course, because we have an example with 0 stars. So of course it makes sense. Now with multiple convolution, it gives us 16. I have just 2 steps. Let's do just 1 step, you know. Sometimes it's better to just do things step by step. So here we have 1, 2, 3, 4, 5, 6, 7, 8. We have 9. And here we're gonna add a bunch of values around it. To be honest, 25 can be whatever, you know. If we do step 2, it should be 0 again, right? Was that it? No, it's 16, so that's not correct. Because here it's going to be all, like the full space is just dots everywhere. Actually, we can just use 1 dot, you know. The full space is just dots. So so it's just zeros. So it means that everything gets changed to a hash. By the way, let's just run that to make sure. 511, and here this is 512 length. So that's the character 511, so that's correct. Actually, let's just write that. So we do the first convolution, and with everything being a dot, then we have the first string, first element that is dash. So, oh, I don't know, actually, I keep saying dash since the beginning, but I think it's sharp. So, yeah, just replace all of the time I've said dash by sharp. Okay, so now, default, so if everything is no, if we have a dot previously and the algorithm 0 is a hash, then default star should be a hash in the future. Oh, wait. Here I need to do else, otherwise. Yeah, otherwise I might change that. Yeah, I might change that twice. Bad move. Okay, we have 0. So now every time it's going to be 0, 1, 0, everything 0. Okay. That was long. Let's go back to 50 steps with the actual example. Have 35 again? No, we're using 2 steps here. We need to go to 50 steps. I'm going to remove here the default here because we need to define 50 just at one place, not every place in the code. Otherwise, you never know which one is used, and it creates more potential for bugs. Here it's going to take forever. Oh my god, it's taking a little bit forever, but we have the right result. So I'm a bit hopeful for that, although it might be also taking forever. Oh, did I copy paste here? Let's run that. We're going to time it. Oh, that was super fast actually. I thought it would take a lot more time. Wait. Yeah, that was the result for the first thing. I think we're good. I think we're good. Let me know if you have some question for today. I hope I was clear. Don't forget to drop a like, to subscribe if you haven't already, and drop a comment to make this video more visible to people who are also working at Advent of Code. Thank you very much for the support on this series, and see you in the next one. Bye bye.